All right, so let's talk about how we're going to graph. We're going to mainly concentrate on sine and cosine, but we are going to go over how to graph all 6 trig functions. So this is the first part of your notes. Basically, it's just reminding you that you can use your knowledge of the unit circle to figure out the patterns in your trig function graphs. And then we're going to break it down to some basics that you'll just remember. So these tables are created by the special angles of the unit circle, and then we're going to just find the sine of that angle. So remember, every angle, every special angle of the unit circle has an ordered pair associated with it, and sine is just the y-coordinate. So we went over, hopefully you watched that review of the unit circle video. If you didn't quite remember your unit circle as well as you needed to do. So 0 is the positive x-axis, the ordered pair is 1, 0, and sine would be the y-coordinate. Pi over 6 is the same as 30 degrees. That ordered pair is square root of 3 over 2, 1/2. Again, sine is the y-coordinate. Pi over 4, we're going to use the unrationalized. If you want to use the rationalized, that's fine. And we're going to continue to write down the y-coordinates. We're going to be plotting these, so it might be helpful if, for the ones that we don't obviously know, if we have a decimal equivalent to help us plot it. Pi over 3 is the same as 60 degrees. That's 1/2 square root of 3 over 2. So square root of 3 over 2 is approximately 0.87. And pi over 2 is the positive y-axis, 0, 1. Now we're just going to actually start repeating because we've already been through the positive x-axis, the positive y-axis, and the first quadrant. So anything with a denominator of 3 is going to relate back to the same ordered pair. It's just that in the second quadrant, we go left and up. So our sine is our y-coordinate still going to be positive. So the 3 values here are going to be the same as they were in the first quadrant where they were also positive. So denominator of 3 would be square root of 3 over 2. Denominator of 4 would be 1 over square root of 2. Denominator of 6 would be 1/2. Okay, pi is -1, 0, so that would be 0. In the third quadrant, it's left and down. So we're going to, again, take the same values that we've already written down based on the denominator, except we're going to make them negative. So 7 pi over 6 would be -1/2. 5 pi over 4 would be -1 over square root of 2, and 4 pi over 3 would be negative square root of 3 over 2. Okay, 3 pi over 2 is a negative y-axis, so 0, -1, so sine is -1. And then in the fourth quadrant, to get in the fourth quadrant, you go right and down. So the sine will also be negative in the fourth quadrant, same values as it was in the third quadrant. So 5 pi over 3 is the same as 4 pi over 3 for sine. 7 pi over 4 is the same as 5 pi over 4 for sine. 11 pi over 6 is the same as 7 pi over 6. And 2 pi is the same as 0. So we're just kind of completing a full circle. Okay, so these are all just related to special angles. Like if I asked you the sine of 2 pi over 3, you should be able to figure out that it is square root of 3 over 2. That's where we're getting these. So when we graph a trig function, our x-axis is labeled with our radians, and then the y-axis is going to still be integers. And the maximum value that a sine function reaches is 1, and the minimum is -1. So the y-axis, I just have to go up to 1 and down to -1. Okay, and then for these initial graphs, we're going to graph all of these points so you can see how the curve or the wave develops. So within each quadrant, exactly halfway is our pi over 4 angle. So we have a pi over 4 angle exactly halfway into each quadrant. And then we have, that's our 45 degrees. Well, we also have 30 and 60. So it would go from 0 to 30. and then 30 to 45 and 45 to 60. And then 60 to 90. So you got to kind of space it out accordingly. It goes from 0 to 30. So that's a 30-degree jump. From 30 to 45 is a 15-degree jump. 45 to 60 is a 15-degree jump. And then 60 to 90 is back to a 30-degree jump. So it's not all spaced out evenly. A lot of times on the unit circle, that's how it'll be drawn, but that's not really accurate. So you're going to just kind of space each quadrant out like that, where you have 45 degrees exactly in the middle, and then 30 and 60 are just on either side. That'll help out develop our curve more accurately. Okay, so now I've kind of, not going to label it, it's just going to be too cluttered, but these hash marks should correspond to every angle that we have up here from 0 to 2 pi. Okay, so the first ordered pair, if the angle is 0, the sine is 0. So the first ordered pair that we're going to plot is 0, 0. So that's really important that our sine graph has a point at the origin. And then we're just going in order here. So our next little hash mark should be related to pi over 6, and that was 1/2. So that ordered pair is pi over 6, 1/2. And then pi over 4 was 1 over square root of 2, but as a decimal, it's 0.71. So just put it like right here. And then our next angle is pi over 3. That was square root of 3 over 2, which is a little bit closer to 1. And then pi over 2 actually reached 1. Okay, and we're just going to continue that. So then we are back down to square root of 3 over 2, which was your 0.87, and then 0.71, and then 0.5, and then you got to pi, and it was back to 0. We're going to continue that, except now we're going to be below the x-axis because now we have negatives. So negative 1/2, negative 0.71, negative 0.86, and then 3 pi over 2 is a negative 1. And then we're going to head our way back up, negative 0.87, negative 0.71, negative 1/2, and then 2 pi was back to 0. Okay, so if you just need to play catch up, you're going to pause the video and take another minute to plot out those points. But if you connect them, you can see it makes a pretty little wave. And that pattern would continue. So that's going to continue in the same direction as long as you continue going around the circle in a positive direction. All right, well, when we graph trig functions, we're not going to have to graph every single point every single time. That would just take way too long. So we're just going to hit the critical points. So it's important for cosine, you want to remember that it goes through the origin. Okay, and we're going to remember all these x-intercepts. And we're going to remember the maximum points and the minimum points. So those are our critical points for our sine and cosine graphs, is the x-intercepts, the maximums, and the minimums. So for a sine graph, through the origin, and then our next critical point is a maximum. Then it goes back down to an x-intercept. Then it hits a minimum, then back to an x-intercept. And that's the pattern that is going to be consistent no matter what. 0 max, 0 min, 0 max, 0 min. So again, though, with sine, what will be important is that you remember origin followed by a maximum. And then we can just follow that pattern over here, 0 max, 0 min, 0 max, 0 min. So this would have to be a minimum to follow the pattern, back to a 0, then a maximum, back to a 0, and the pattern continues. And there's your sine graph. So for your sine graph, this is y equals sine x. This is the parent function for sine. The domain is negative infinity to infinity because we can keep going around the circle forever. The range has a minimum of -1 and a maximum of +1. Okay, and you just want to really remember that it goes through the origin followed by a maximum. Okay, those points I put asterisks for, that's going to distinguish it from cosine. All right, we're just going to repeat this process, except with cosine. I'm going to probably speed it up a little bit because we've already talked about how we're even going to get these points. So it's the same ordered pairs that we wrote the first time, except the cosine is the x-coordinate. So we don't have to go through and rewrite all the ordered pairs. We just need the x-coordinate of those angles to determine how to fill in the table. So 1 comma 0, x-coordinate is 1, square root of 3 over 2 comma 1/2. Remember, that's about 0.87. Pi over 4 is 1 over square root of 2. That's about 0.71. Pi over 3 would be your 1/2. Pi over 2 is 0 comma 1. Again, we're writing the x-coordinate for cosine. In the second quadrant, we're going left and up. The x-coordinate is negative. So we're going to use the same values that we used here, except in the second quadrant, cosine is negative since you're going left. So this would be negative 1/2, negative 1 over square root of 2, negative square root of 3 over 2. Pi is negative 1, 0. In the third quadrant, it's left and down, so x is negative, y is negative. So the third quadrant is going to be exactly the same as the second quadrant for cosine based on the denominator. Three pi over 2 is 0 comma negative 1. And then the fourth quadrant, we go right and down. So it's the x-coordinate that is positive again. So the fourth quadrant is the same as it was in the first quadrant. Again, base that on your denominator being the same to get the right value. And 2 pi is the same as 0. So that's back to 1. Okay, if we do the same thing, just this first time graphing. So remember, your pi over 4 is exactly halfway in between each quadrant. And then 30 and 60 fall on either side of the 45. The maximum y value is still 1. The minimum is still negative 1. So we kind of get our axes set up, and then we can go through and plot these points. So this one does not go through the origin. It has the ordered pair 0 comma 1. So it starts with a maximum point on the y-axis, which is what differentiates it from the sine function. Then we've got 0.87, 0.71, 1/2, 0. Now we're hitting the negatives. So negative 1/2, negative 0.7, negative 0.87, negative 1, go back up, negative 0.87, negative 0.7, negative 1/2, back up to 0, and finishing off back in the positives, we've got the 1/2, 0.71, 0.87, and 2 pi back to 1. And then if we just connect those points, again, if you're needing more time, just pause your video and finish plotting your points. But you want to continue the pattern. So it doesn't just stop. There's an arrow there. The pattern is the same for sine, 0 max, 0 min, 0 max, 0 min. So the only thing that can follow over here is the 0. Then it would have to be minimum, back to 0, followed by a maximum, because it has to go in that order. Okay, so we can kind of complete our curve over on the other side. And this is what our parent function looks like. What we want to remember here with the sine, we wanted to remember origin followed by the maximum. Here, if we just remember that the cosine starts with a maximum on the y-axis, the only thing that can follow that is the x-axis, x-intercept. So we only really have to remember it starts with a maximum. So this is the parent function for cosine. The domain is still negative infinity to infinity because you can keep going around the circle as many times as you want. The range is still low of -1, maximum of +1. Okay, so again, when we actually graph these with Euler transformations, we're going to just concentrate on the critical points. We just plotted all the points so you could see how the curve actually develops. So let's just sort of run through that with tangent as well. Same special angles. Remember, tangent is sine divided by cosine or y divided by x. So I'm just going to fill in quickly, because you can always go back and figure out for a specific angle if that is the right tangent value based on your unit circle. The tangent of 0 is 0. The tangent of pi over 6 is 1 over square root of 3, which is about 0.58. Pi over 4 would be 1. Pi over 3 is square root of 3, which is about 1.7. Pi over 2, undefined. Remember, tangent, now we can have where we're dividing by 0 and it's undefined. And on our graph, that's going to mean we have asymptotes, which we didn't have with sine and cosine. Second quadrant for tangent is negative, because we have a positive divided by a negative for anything in the second quadrant. So if we just look at what we put in the first quadrant, we can just make those negative answers. Pi, the order pair is negative 1, 0. We do 0 divided by negative 1, get 0 again. Third quadrant, tangent is positive, because we have a negative x and a negative y, so you have a negative divided by a negative. So same values that we used in the first quadrant, we're going to use in the third quadrant. And then 3 pi over 2 is undefined again, because you would have 0 divided by 0 comma negative 1. So to get the tangent, it would be negative 1 divided by 0. Can't divide by 0. Fourth quadrant, tangent is back to being negative, because again, you would have a negative divided by a positive. So this would be negative square root of 3, negative 1 over square root of 3. And 2 pi was the same as 0. Okay, so we can do the same thing we did before. The pi over 4 angles exactly halfway into the quadrant, the pi over 3, the pi over 6 on either side of that. The y-axis is a little bit different, though, because you can see we do have values that are bigger than 1, are smaller than negative 1. So for here, we want to go up to 2 and down to negative 2. So that we have room for all the y values. All right, so I'm going to start plotting these points. 0, 0, so tangent goes through the origin, just like sine. The next angle is a little bit more than half, then up to 1, then almost up to 2. Now we're up to 1.7. Pi over 2 is undefined, though, so that's an asymptote, vertical asymptote. All right, now we're hitting some negatives. So negative square root of 3 would be like negative 1.7. And then negative 1. And negative 1 over square root of 3, that's negative 0.58. Then we hit 0. Then we're back up to the positives again. So 0.58. And then 1. And then 1.7. And then we have another asymptote. And that pattern can continue, except now we're going to be down here. So we've got our negative 1.7, negative 1, negative 0.58, and 0. All right, so these are not plotted the best they could be, but basically where we have a whole complete section right here between these two asymptotes, if you connect these dots, you want to make it look like a cubic function. And that's the pattern that you have for tangent. You're going to have the asymptotes at all your pi over 2's. The zeros are halfway in between. And the curves are cubic functions between your asymptotes through the x-axis. And that's what your tangent graph looks like. So this is your parent function, y equals tangent x. The domain for this one's a little special because we can't have, we have undefined at all our pi over 2's. So our domain here is that x cannot equal pi over 2. And we say pi over 2n, where n is an odd integer, because it's 1 pi over 2 and 3 pi over 2 and 5 pi over 2 and negative 1 pi over 2. It wouldn't be 2 pi over 2 because that would be pi. The range is negative infinity to infinity because we have these cubic curves. So the important points for tangent are where the asymptotes are at all your pi over 2's, and that the zeros are exactly halfway between at your origin and then your pi's. So for your reciprocal functions, basically you take what you know about sine, cosine, and tangent, and that's how you get your reciprocal trig function. So for cosine or cosecant, we're going to look at sine first. So remember, we had on our y-axis, it went up to 1 and down to negative 1. And for sine, remember that it went through the origin followed by a maximum. So I'm just going to plot all my critical points for sine. It went 0, origin, up to a maximum, 0, then back to 0. That was the pattern for sine. Okay, so I'm going to kind of dash this. This is the sine graph. It is not the cosecant graph. Okay. All right, so for the reciprocal function, think about the reciprocal of these critical values that we've plotted. The reciprocal of 1 is 1. So anywhere the sine is 1, the cosecant would also be 1. And the reciprocal of negative 1 is negative 1. So anywhere the sine is negative 1, the cosecant would also be negative 1. Now, the reciprocal of 0 is undefined. So everywhere the sine graph has an x-intercept, that would be an asymptote for cosecant. And then to finish off the cosecant curve, you take all those max and mins that are still there and between the asymptotes, and you can kind of flip up these little parabolic shapes that are fenced off. And so everything I just drew in pen, that is your cosecant graph. And we just do the same thing for secant, except we base it off of cosine. So remember the cosine, the critical points, maximum on the y-axis. And the pattern is 0 max, 0 min. So after that maximum, it would have to go 0, then minimum, back to 0, maximum, because it has to follow that pattern. And again, I'm just going to dash this graph. And do the same thing I did for cosecant. The reciprocal of 0, or sorry, the reciprocal of 1 is still 1. So all the maximum points are still there. The reciprocal of negative 1 is still negative 1. But everywhere that the cosine is 0, that is now undefined for secant. And then in between every set of asymptotes, you just flip over those little parabolas that are fenced off. And what's in pen would be your secant graph. Okay, and then for cotangent, so this one, if you try and do the tangent and the cotangent on the same graph, it gets super messy looking. So I'm just going to kind of talk through it. So the important things to graph on tangent and cotangent are the x-intercepts and the asymptotes, and everything is just backwards. So for the tangent graph, the asymptotes are at the pi over 2's and the x-intercepts are at the origin and pi. That just gets reversed for cotangent. So for cotangent, we're going to put the asymptotes at the origin and pi, and we're going to put the x-intercepts at the pi over 2's, the opposite of what we did for tangent. And then the curve, instead of being a cubic curve, it is just a negative cubic curve. And that gives us our cotangent graph. Our tangent graph. Okay, so that's sort of your introduction to graphing. Now we're going to get into some specifics. How do we graph if we have transformations? So that is the next part of your note. So you can see that the graphing form for sine and cosine is exactly the same, except one says sine and one says cosine. So we spent a lot of the year doing transformations with AH and K, but for trig graphing, we're going to have four transforming values. So we use A, B, C, and D. A is going to be the coefficient on the trig function. That is the amplitude. Amplitude, you want to look at it as an absolute value because it is the distance away from the horizontal center of the graph. So a distance is always positive. This is going to affect the y-axis. This is the amplitude is going to tell us about how the y-axis needs to get labeled. The period is your b. The b value is between the trig function and the x. It should always be factored away from the c value as it is up here. And the period is how long it takes to complete one full pattern or one full circle. And so normally that would be a 1. And as you can look back at your graphs for sine and cosine. So it took from 0 to 2 pi to go all the way around the circle. Here's the top half of the circle. Here's the bottom half of the circle. And it took from 0 to 2 pi. So the period for sine and cosine is normally 2 pi. If there is a b value, we are going to have a different period, a different amount of time to get around the circle. It's either going to be longer or shorter. And we take what is normal for sine and cosine and divide by that b value. And that gives us our new period length. We're going to use that to rescale our x-axis. So if the period is 2 pi, we always just label our x-axis by the axes of the unit circle, pi over 2, pi, 3 pi over 2, 2 pi. But if there is a different period for a graph, we're going to rescale the x-axis based on this new period by taking the new period and dividing by 4. C is your phase shift. That's the same as your H from everything else we've graphed. That tells you to go left or right, opposite of the sign. The vertical shift is D. That's like your K value from everything else we've graphed. It tells you to go up or down with the sign. Okay, so the period is affecting the x-axis. The phase shift will affect points along the x-axis left or right, and the vertical shift is back to the y-axis. So 2 of these transformations are related to the y-axis and 2 to the x-axis, and that's just going to be important for the order in which you do things and how you label things. Okay, so we're going to start out with something really simple. The only change we have here is we have a b value of 2. And a lot of times the most complicated part of graphing with transformations for sine and cosine is that b change. So we want to start out with that. So that is going to change the period, which is normally 2 pi for a sine graph. So what we do when b equals 2, we take what is normal for sine or cosine and do 2 pi divided by b. In this case, 2 pi divided by 2, so that's pi. That's the new period. That's how long this graph is going to take to complete a full circle. So you can see it's half as long as normal. Then we're going to use that to scale our x-axis. So we're going to take our new period, pi, and divide it by 4. Why 4? Because we normally do pi over 2, pi, 3 pi over 2, 2 pi. Okay, so we normally have 4 things labeled, and we want to still have 4 things labeled, but we need to know how to label them. So we always want to do 2 pi, and we always want to divide by 4. Okay, the things that will change are what your new period is when you divide by the b value, and then that new period divided by 4. So if the scale is 4, that's how we want to count out our x-axis. So this would be pi over 4, and then that's 1 pi over 4. So you want to do 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Okay. To kind of make sure you're on the right track, whatever you said the new period is, that should be the 4th thing labeled. But this is what you're counting by. So this is 1 pi over 4. So this would be 2 pi over 4, 3 pi over 4, 4 pi over 4. Well, 2 pi over 4 reduces to pi over 2. And then 3 pi over 4 and 4 pi over 4 reduces to pi. Okay, so the scale is pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. The new period is always going to be that fourth label. Whatever you label on the positive side, you do the exact opposite. On the negative side, negative pi over 4, negative pi over 2, negative 3 pi over 4, negative pi. And that was the only change for this one. So a normal parent function for sine or cosine has a maximum of 1 and a minimum of -1. So that's not going to change at all. We only had the change in period here. And we've accomplished that by relabeling our x-axis. Okay. So once you've relabeled your x-axis to account for the period change, then we're ready to graph. So what we needed to remember about sine is that it went through the origin and was followed by a maximum, and that it always has the same period of 0 max, 0 min. So if we remember that it goes to the origin followed by a maximum, then we can just use our pattern to graph all the other points. And there's our graph. Remember, it's got arrows on either end to represent the fact that that pattern will continue in this way forever. It's important to realize that we are making our life easier by taking any period change and using it to relabel our x-axis, but that if you were then to put this on a calculator, the calculator doesn't do that. The calculator always labels the x-axis by pi over 2, pi, 3 pi over 2, 2 pi. So if you were to graph this same function on the calculator with a period that was half of what is normal, then you would see a wave that looked like it was going twice as fast. Okay, so it's not going to look exactly like this because we have, to make our life easier, we have relabeled this x-axis so that it always looks like it's going the same speed. But on the calculator, it doesn't do that. So it would look like the wave was going faster if we put it on the calculator. Just keep that in mind, that if you try and relate that back to the calculator, it's not going to necessarily match up to what you're expecting. All right, so let's try one that's got a little bit more in it. Usually want to start with that period change because that's got the most, I guess, computation with it. So here we have b equals 1/2. So 2 pi divided by 1/2. Dividing by 1/2 is the same as multiplying by 2. So that is the same as 4 pi. Okay, that's our new period. So our scale would be our new period divided by 4. So it's pi. So let's go ahead and take care of that. So 1, 2, 3, 4, and it's going to count by pi. 1 pi, 2 pi, 3 pi, 4 pi. The fourth mark should always be the same as what you said for the new period. And then on the negative side, don't be lazy. You need to label that too. Just whatever you already said on the positive side, just make it negative. Okay, so that's taken care of. I don't have to think about that again. I have 2 more transformations in this one. The amplitude is 3. That's going to affect the y-axis. And the vertical shift also affects the y-axis, but that would be found back here. So I don't have a vertical shift. So the only thing that's going to affect how I label the y-axis is my amplitude. And that just means that instead of having a maximum of 1 and a minimum of -1, it's going to have a maximum of 3 and a minimum of -3. Okay, it's going to go 3 units above the horizontal middle and 3 units below. So once I have labeled my y-axis with this amplitude, I kind of can forget about that one. The last one is the phase shift. And the phase shift is like your h. Phase shift is pi to the left. Remember, it's opposite of the sine. The phase shift would always be the last thing that you do. Okay, because you label your x-axis with the period, you can label your y-axis with the amplitude, and if there's a vertical shift, you'll incorporate that. But then the phase shift is when you're ready to plot the first point. Okay, so here's what you do. This is cosine. Think about how a cosine normally starts. So a cosine normally starts with a maximum on the y-axis with an amplitude of 3. That'd be up here at 0, 3. Okay, but I'm not actually going to put that point there. There's a phase shift of pi to the left. So instead of putting that maximum on the y-axis, I'm going to shift that pi to the left, and that is my first point. So put your pencil where you normally would start your cosine or sine graph, and then move according to the phase shift and put your first point there, and then you can use the pattern from there. So your first point is a maximum here. That always has to be followed by a 0, then a minimum, back to 0, maximum, back to 0, and just keep working that pattern. And we have our graph. Okay, so we have another example. This also has a period change, a phase shift. It has an amplitude. This time the amplitude has a negative in front of it, so we have to talk about what happens there. Okay, so I always start with the b value first. That is 1/3. So 2 pi divided by 1/3, dividing 1 by 1/3 is the same as multiplying times 3. So 6 pi is my new period. So my scale would be 6 pi divided by 4, which is 3 pi over 2. Okay, so 1, 2, 3, 4. So I always know that fourth mark is whatever I said the new period was. The scale is what I count by. So 3 pi over 2, and then 3 pi over 2 plus 3 pi over 2 is 6 pi over 2. You're just adding 3 pi to the numerator. So 3 pi over 2 plus 3 pi over 2 is 6 pi over 2, but 6 pi over 2 is 3 pi. And 6 pi over 2 plus 3 pi over 2 is 9 pi over 2. And 9 pi over 2 plus 3 pi over 2 is 12 pi over 2, which is 6 pi. So that was 3 pi over 2, 6 pi over 2, 9 pi over 2, and 12 pi over 2. We're just adding 3 pi to our numerator each time. Whatever we put on the positive side, we want to have on the negative side. Okay, so we've taken care of the period. Again, we don't have a vertical shift. I'm going to add one example on so that we have some vertical shift in there from what's in the notes. So let's look at the amplitude next. The amplitude is 2. So that's going to mean that my y-axis needs to go as high as 2 and as low as -2 for the amplitude of 2. But also the amplitude has a negative value with it. That negative means that max and min are going to switch because it's going to be a reflection over the x-axis. So everywhere you would think about putting a maximum is not going to be a minimum and vice versa. Okay, and then we have, lastly, our phase shift. It's 3 pi, opposite of sine to the left. That's the last thing you do. The x-axis got labeled from our period change, done with that. We labeled our y-axis for the amplitude, and we made a note that we're going to have to switch all our max and mins. And now we're ready to put our first point on the graph, and we have to then incorporate our phase shift of 3 pi to the left. So remember, for sine, that normally starts at the origin. So I normally would be putting my first point right here, but now I think about my phase shift. My phase shift is 3 pi to the left. So that first point that would normally be at the origin is right here. And then normally for sine, after you put that origin point, it's followed by a maximum. Well, here's that origin point shifted 3 pi to the left, but instead of hitting a maximum, this one has to go down to a minimum first because all my max and mins need to switch. So here's the origin point shifted, followed by a minimum because of this, and then you can follow your pattern. Zero max, zero min, 0 max, 0 min. Okay, so I don't know if you noticed, but this actually looks the same way as just sign would look with going through the origin and following by the maximum. So what happened here is the phase shift and the switching of the max and the min kind of undid each other. Okay, so that basically I ended up with the same graph as if neither one of these things were here. And I only had just an amplitude of 2 and a period change. All right, I'm going to do one more example with you because there was none included with a vertical shift, and I wanted to make sure that I was thorough and went through all those changes with you. Okay, so we're going to do y equals negative cosine 2 times the quantity x minus pi over 2 minus 3. So just like the other examples, let's start with the period. So b equals 2. So 2 pi divided by 2 equals pi. That's the new period. So my scale is pi divided by 4. Right, so okay, so pi over 4, that's what we're going to count by. Remember, the fourth thing should be whatever you said the period was. I think this is the same as we did for the first example, counting by pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And we could reduce 2 pi over 4 and 4 pi over 4. And then whatever you said on the positive side, just make it negative. On the negative side, all right, so that's taken care of this. For the amplitude, if you have to look at amplitude and vertical shifts kind of together to label your y-axis. So the vertical shift says we need to move 3 down, and the amplitude is still 1, but we need to switch our max and mins. So if the amplitude is still 1, that's going to not really affect, how far up and down it goes. It's still just going to go 1 unit from the horizontal middle. But anything that was on the x-axis, everything's shifting down 3 here. So I'm going to shift down 3 from the x-axis. And I always like to put a horizontal dotted line. It's not an asymptote. It's just reminding me that anything that was on the x-axis now is going to be down here. And then you want to make sure you can continue to scale the y-axis based on whatever the amplitude is. So in this case, the amplitude was just 1. So I only need to have a maximum that'll go 1 unit above where all my zeros are and 1 unit below. Okay, so that's all I need. Obviously, you still have the x-axis, so you do need that labeled, but I'm not going to have any part of the graph up here. Anything that was going to be on the x-axis is going to be on this horizontal midline, and then the amplitude says that the maximums will be 1 unit above that, and the minimums will be 1 unit below that, and we are going to switch our max and mins. I'm not quite ready for that. The last part is the phase shift. That says to go pi over 2 to the right. Okay, so I've got my x and y axis labeled. I'm ready to put the first point on the graph. That's the time that you want to consider any phase shifts. So it's cosine. Cosine normally starts with a maximum on the y axis. Well, here's kind of where my origin has moved because everything went down 3 and the amplitude is 1. So the maximum would now be down here at -2. But remember, we were switching our max and mins. So instead of starting this graph with a maximum on the y-axis, this one's going to start with a minimum, which is 1 unit below that horizontal midline. Now think about the phase shift. The phase shift says to go pi over 2 to the right. So we have figured out that between the amplitude, the vertical shift, and the switching of the max and the mins, this would be where our first point was. We need to move pi over 2 to the right. And that's our first point. That's a minimum. So your pattern, 0 max, 0 min, all we need to know that because then it would have to go 0, maximum. This would have to be back to 0. This would be a maximum, 0, minimum, 0, maximum. Okay. So let's kind of go over that one more time. We labeled our x-axis because of the period change. That was taken care of. We needed to move all points down 3. So we got sort of a new horizontal midline, and anything that would have been on the x-axis is now down here. The amplitude is 1, so I only need to go 1 unit above for maximums and 1 unit below that horizontal midline for minimums, but I do need to switch all my max and mins. So this would have been the maximum, but we started here, but then we incorporated that phase shift of pi over 2 to the right, and this was the first point that we plotted. That's a minimum, so it has to be followed by a 0, and then a maximum for the pattern to be completed. And then if you go back, it is obviously moved everything down 3, but it ended up that we still ended up with a maximum on the y-axis. So just like the previous example, between the switching of the max and the mins and the phase shift, they kind of undid each other. That doesn't always happen. If this graph had moved 3 pi over 4 to the right, then that first point would have been here, and these things would not have undone, would just not undo each other. Okay, so that completes your notes, and you should be able to do your practice problems, check in with me on office hours if you have questions, and then do the this week's assignment.